Dr. Kim Seok adjusted his tie for the 10th time that morning. His hands shook slightly as he looked through the thick glass wall at the aliens sitting in the evaluation room. After 3 years of preparation, humanity's first application to join the Galactic Council was finally happening. The aliens called themselves the Valari. They looked like giant crystals that had learned to walk. Their bodies were tall and sharp, catching light from every angle. When they moved, they made soft musical sounds like wind chimes. Seok had spent months learning their language, but he still found their appearance both beautiful and frightening. "Are you ready, Dr. Kim?" asked his assistant, Park Jin-soo. The young man carried a tablet loaded with every achievement humanity had made in the past century. Space stations, quantum computers, medical breakthroughs, fusion power plants. Everything. That proved humans deserved a place among the stars. Seok nodded and walked into the evaluation room. The lead Valari, who called itself Quentalith, barely looked up from its glowing tablet. Its voice sounded like singing when it spoke. "Begin your presentation, human representative." The next 2 hours felt like the longest in Seok's life. He showed them images of the International Space Station. The Valari seemed bored. He explained quantum computing advances that had taken human scientists decades to achieve. Quentalith made a sound that might have been a yawn. When Seok described fusion reactors that could power entire cities, the alien delegates started whispering among themselves in their musical language. "Is this the extent of your technological development?" Quentalith asked when Seok finished. "Well, no. We have medical advances that have extended human lifespan by decades. We have artificial intelligence that can process massive amounts of data. We have vehicles that can travel to other planets in our solar system." The Valari exchanged more musical whispers. Seok caught a few words he recognized. Primitive was one of them. Limited was another. "Your energy manipulation methods are crude," Quentalith announced. "Your computational systems lack sophistication. Most concerning, your mathematical understanding appears restricted to basic operations necessary for stellar navigation." Seok felt his heart sink. "But we've solved complex equations. We understand physics, chemistry, biology." "Elementary applications," another Valari interrupted. Its name was something Seok couldn't pronounce, so he just called it Delegate 2 in his mind. "Your mathematics show no advancement beyond what most species achieve within their first 1,000 years of development." In the observation area, Dr. Park Hana shifted in her uncomfortable plastic chair. She wondered why she had been included in this delegation at all. As a marine biologist, she had nothing to offer a discussion about space technology and advanced mathematics. The Korean government had insisted that every major scientific field should have a representative present just in case. Now she felt like she was wasting everyone's time. The evaluation continued poorly. Every human achievement the aliens dismissed as basic or unimpressive. Seok's careful presentation fell apart as the Valari showed little interest in anything humanity had accomplished. "What about our partnerships with other Earth species?" Seok asked desperately. "We work closely with dolphins and whales in our ocean research. They help us understand marine ecosystems and assist with underwater exploration." This finally got a reaction from the aliens, but not the kind Seok hoped for. Quentalith's crystal body seemed to vibrate with what Hana recognized as laughter. "You depend on lower life forms for basic data collection?" Quentalith said. "This demonstrates exactly what we suspected about your limitations. A truly advanced species develops technology to replace such primitive methods." Hana felt a flash of anger. She had spent 15 years working with dolphins and whales. These weren't lower life forms. They were intelligent, complex creatures with their own personalities and capabilities. But she kept quiet. Speaking out would only make things worse for humanity's application. The evaluation ended with predictable results. Humanity received provisional status, essentially a polite way of saying, try again in a few hundred years. The Valari would file their report with the Galactic Council, recommending that Earth be placed on the waiting list for species not quite ready for galactic civilization. Your species shows potential, Quentalith said, as the aliens prepared to leave. Continue developing your mathematical and technological capabilities. Perhaps in time, you will achieve the sophistication necessary for council membership. As the Volari gathered their equipment, Hana noticed something on one of their display screens. It showed a complex mathematical proof they had used to demonstrate advanced alien thinking. But there was something wrong with it. A small error in the topological calculations that changed the entire result. Hana stared at the equation. Just 3 months ago, she had been working on a similar problem with her research partner at the Marine Institute. The problem involved mapping three-dimensional underwater current patterns, and it had taken weeks to solve. But her dolphin partner, Dong Hyun, had helped her spot exactly this kind of error in their initial calculations. She wanted to point out the mistake to the aliens, but they were already heading toward their transport ship. Besides, what did a marine biologist know about advanced alien mathematics? The Volari were clearly far more sophisticated than humans. If their proof had an error, they would find it themselves. After the aliens left, the human delegation sat in stunned silence. 3 years of preparation had resulted in complete failure. Earth would remain isolated from galactic civilization, at least for now. "What do we do next?" asked Park Jin-soo. Siak rubbed his temples. "We go back to the drawing board, focus on advancing our technology and mathematics. Maybe in 50 years we can try again." But Hana wasn't listening to the post-evaluation discussion. She kept thinking about that error in the Volari proof. It was exactly the same type of mistake that Dong Hyun had helped her catch. The dolphin had an incredible ability to spot patterns that didn't quite fit, even in complex three-dimensional problems. Could it be possible that Earth's marine mammals understood mathematics better than anyone realized? The idea seemed ridiculous, but Hana couldn't shake the feeling that humanity had just missed an important opportunity. As the delegation packed up their materials and prepared to return to Earth, Hana made a decision. She would go back to her research with the dolphins and whales, not to prove anything to the aliens, but because she had a growing suspicion that humans didn't understand their own planet as well as they thought they did. The Volari ship disappeared into the stars, carrying with it humanity's failed application. But in a small research facility on Jeju Island, something extraordinary was about to be discovered. Something that would change everything the galaxy thought it knew about intelligence, mathematics, and the true nature of Earth's most remarkable minds. 3 months had passed since the failed meeting with the Galactic Council. Dr. Park Hana tried to forget about the disappointment by focusing on her work at the Jeju Island Marine Institute. The ocean always calmed her mind, and her research with dolphins and whales gave her purpose, even when the rest of the world seemed to have given up on reaching the stars. Her colleague, Dr. Choi Jin, worked beside her that morning, checking the underwater cameras they had installed around the research area. The cameras recorded everything the marine mammals did, helping the scientists understand their behavior patterns better. "Look at this, Hana," Jin said, pointing to his computer screen. "The dolphins are doing something different today." Hana moved closer to see the footage. In the clear blue water, a group of bottlenose dolphins swam in perfect formation. But they weren't just swimming. They were creating patterns with their movements, circles and spirals that seemed too organized to be random play. "How long have they been doing this?" Hana asked. "About 2 hours, and it's not just random movement. Watch this part." Jin replayed the video from earlier that morning. The dolphins, led by the one Hana had named Dong Hyun, moved through the water in complex geometric shapes. They used streams of bubbles from their blowholes to mark points in space, creating three-dimensional designs that hung in the water like invisible sculptures. Hana grabbed her notebook and started sketching what she saw. The patterns were mathematical. Not simple shapes like circles or triangles, but complex relationships between multiple elements. It looked almost like the dolphins were solving equations in the water itself. "This is new behavior," she said. "I've never seen them create patterns this organized before." Over the following weeks, the behavior became more frequent and more complex. The dolphins weren't the only ones participating. The resident whales had started their own unusual activities. Beck Ho, an elderly humpback whale who had lived in the research area for 5 years, began producing songs unlike anything Hannah had heard before. Whale songs were nothing new. Scientists had been studying them for decades. But Beck Ho's new songs had structure and rhythm that seemed mathematical. When Hannah recorded them and converted the sound patterns into visual graphs, she saw something that made her heart race. The graphs looked like mathematical proofs. "This can't be right," she told Jin as they studied the printouts. "These patterns are too complex for coincidence." Jin adjusted his glasses and looked at the data again. What if they're not coincidental? What if the whales are actually thinking through problems? It sounded impossible, but the evidence kept growing. More whales joined Beck Ho's musical sessions. Their combined songs created layered harmonies that, when analyzed, revealed mathematical relationships Hannah had never seen before. The dolphins continued their bubble pattern activities, working together to create increasingly sophisticated designs in the water. After a month of documenting these behaviors, Hannah knew she needed help. She called Dr. Lee Soo-jin, a mathematician, from Seoul National University who had helped her with complex calculations in the past. "I need you to look at some patterns for me," Hannah said over the phone, "but I can't tell you where they come from yet. I just need you to tell me what you see." Soo-jin arrived at Jeju Island 3 days later. Hannah handed her folders full of data without explaining their source. The mathematician spent hours studying the graphs and equations, her expression growing more amazed with each page. "Where did you get these?" Soo-jin finally asked. "Just tell me what you think they represent first." Soo-jin spread the papers across the table. "These are mathematical proofs. Elegant ones. This sequence here solves a problem in dimensional geometry that I've been working on for 2 years. And this pattern represents calculus operations that would take our best computers weeks to process." Hannah took a deep breath. "They came from the whales and dolphins." Soo-jin stared at her. "That's not possible. Come with me. I'll show you." They went out to the observation deck overlooking the research area. Below them, Dong-hyun and his pod were creating their bubble patterns again. The dolphins moved with purpose, each animal contributing to a larger design that grew more intricate by the minute. "Watch how they position themselves," Hannah said. "Each dolphin represents a variable in an equation. When they move, they're manipulating the relationships between those variables." Soo-jin watched in silence for 20 minutes. Then Beck Ho's song began echoing across the water. Other whales joined in, their voices weaving together in complex harmonies. "This is impossible," Soo-jin whispered. "But I can see it. They're solving problems. Real mathematical problems." The breakthrough came when they realized the dolphins and whales were working together. The dolphins would create a pattern representing a problem. Then the whales would respond with songs that provided solutions. It was like watching a conversation between different types of mathematical minds. "Look at this recording from yesterday," Hannah said, showing Soo-jin the analysis. The dolphins presented a geometric problem using their bubble formations. Within an hour, Beck Ho had composed a song that contained the solution. But the most amazing discovery was still to come. Jin noticed that the whales' songs were being heard by other whale populations far from Jeju Island. Marine research stations across the Pacific started reporting similar mathematical behaviors in their local whale populations. A humpback whale off the coast of California sang a complex mathematical sequence. Within days, whales near Japan were singing variations of the same sequence, but with improvements and additions. They were sharing mathematical knowledge across thousands of miles of ocean. "It's like a network," Soo-jin said, as they mapped the communication patterns. "The whales are teaching each other. Each population contributes to the overall mathematical understanding." Hannah felt overwhelmed by the implications. What if the aliens were wrong? What if Earth does have advanced mathematical minds, but we never looked in the right place? The team began documenting everything. Every whale song, every dolphin pattern, every interaction between species. They created translation programs that could convert cetacean behaviors into human mathematical notation. The results were staggering. Earth's marine mammals weren't just playing or communicating. They were thinking. They were solving problems that challenged human understanding. And they had been doing it for who knows how long, hidden beneath the waves where humans rarely looked. "We need to contact the government," Jin said, after reviewing weeks of data. Hana nodded, but her mind was already racing ahead. If the cetaceans could solve problems this advanced, what would happen when they encountered the mathematical challenges that had stumped the Galactic Council? Could Earth's whales and dolphins succeed where human technology had failed? As the sun set over Jeju Island, the whales began their evening songs. But now Hana heard them differently. These weren't just beautiful sounds echoing across the water. They were the voices of mathematical geniuses, sharing knowledge and solving problems that could change humanity's place in the galaxy forever. Dr. Yoon Tae-min arrived at Jeju Island on a gray morning in late October. He carried with him classified files from the Korean government and a proposal that sounded like science fiction. As the country's lead expert on alien biology, he had spent months studying the Valari mathematical systems from their evaluation visit. "I think your whales and dolphins might understand alien mathematics better than we do," he told Hana and her team during their first meeting. Jin nearly choked on his coffee. "That sounds impossible." "So did everything we discovered about cetacean intelligence," Hana replied. "What makes you think this, Dr. Yoon?" Tae-min opened his laptop and showed them recordings from the failed Galactic Council evaluation. "Look at these Valari equations. They use geometric patterns that exist in multiple dimensions at once. Human minds can only understand them with computer help, but your marine mammals naturally think in three-dimensional space." He pointed to footage of the dolphins creating their bubble patterns. "When Dong-hyun and his pod make these formations, they're manipulating relationships in exactly the same way the Valari mathematics work. The whales do something similar with sound patterns that exist in multiple layers." Soo-jin leaned forward, studying the alien equations. "You want us to test whether the cetaceans can solve Valari problems directly?" "Exactly. If they can, it might change how the galaxy sees Earth." The first experiment took place 3 days later. Tae-min had created holographic projections that could display three-dimensional mathematical problems underwater. The technology was experimental, borrowed from a defense research lab in Seoul, but it worked well enough for their purposes. They started with simple Valari geometric problems, basic shapes that required understanding of how multiple dimensions connected to each other. Hana felt nervous as they lowered the holographic projector into the water where Dong-hyun's pod usually gathered. The dolphins approached the glowing shapes with curiosity. At first, they just swam around the projections, investigating this new addition to their environment. But then, something remarkable happened. Dong-hyun began moving through the geometric pattern, his body tracing paths between different elements of the equation. Other dolphins joined him, each one taking position at key points in the three-dimensional structure. Within an hour, they had rearranged themselves into the solution. "They solved it," Tae-min whispered, checking his calculations. Not only that, they found the most efficient solution path. The team ran more tests over the following weeks. Each Valari problem they presented, the dolphins solved faster than the previous one. But the whales proved even more impressive. When they played Valari mathematical sequences through underwater speakers, Baek-ho and the other humpbacks responded with songs that contained improved versions of the original problems. They weren't just solving the equations, they were finding better ways to solve them. The breakthrough came when they tested the cetaceans with an advanced problem that had taken Valari mathematicians decades to solve. It involved understanding relationships between 11 different dimensions, something that human minds couldn't grasp even with computer assistance. They introduced the problem to Sölgi, a female orca who had recently joined the research area. Orcas had always been known for their intelligence, but Sölgi's response exceeded every expectation. Working with Dr. Kang Minho, who had trained marine mammals for 15 years, they presented the 11-dimensional problem using a combination of holographic displays and sound patterns. Sölgi studied the projection for several hours, swimming around it and occasionally touching specific points with her rostrum. Then she began to work. What happened next would be talked about in scientific circles for years to come. Sölgi manipulated the holographic projection with movements so precise and purposeful that it was clear she understood every aspect of the 11-dimensional structure. She moved through mathematical space like a master artist creating a sculpture. "She's not just solving it," Sujin said, her voice filled with awe. "She's showing us new ways to think about dimensional mathematics." But the most amazing discovery was yet to come. The cetaceans began working together on problems that none of them could solve alone. Dolphins provided rapid pattern recognition, identifying key relationships quickly. Whales offered deep processing power, working through complex calculations. Over hours or days, orcas synthesized the results, combining different approaches into elegant final solutions. It was like watching a living computer made of conscious minds, each species contributing their unique cognitive strengths to solve problems that challenged even advanced alien civilizations. News of the discoveries spread through classified government channels. Within weeks, research teams from Russia, Japan, and the United States were reporting similar phenomena in their own marine mammal populations. Arctic whales were demonstrating mathematical abilities that matched what they saw at Jeju Island. Pacific dolphin pods were collaborating on problems across thousands of miles of ocean. "It's happening everywhere," Jin told the team during one of their evening briefings. "Marine mammals around the world are showing these capabilities. It's like they were waiting for us to notice." The Korean government decided it was time to contact the Galactic Council again. If Earth's cetaceans could solve problems that challenged even the Valari, perhaps humanity deserved a second evaluation. Taemin sent a formal request to the aliens, accompanied by video evidence of the mathematical achievements. The message was simple. Earth requested a new evaluation based on previously overlooked intelligence on their planet. The response came faster than expected. Quentalith's reply was brief but intrigued. "Your claims seem impossible. However, we will observe a demonstration of these alleged capabilities." As Hana stood on the dock that evening, watching the whales sing their mathematical songs across the darkening water, she felt hope for the first time since the failed evaluation. Earth might not have impressed the aliens with human technology, but perhaps they had been looking at the wrong species all along. The ocean held minds that thought in ways no land-dwelling creature could imagine. Mathematics flowed through their thoughts like water itself, natural and powerful. Soon the galaxy would learn what Earth's true intellectual treasures had been all along. Tomorrow, they would show the aliens that intelligence takes many forms, and sometimes the most profound minds live beneath the waves. Dr. Oh Hyun-woo stood on the deck of the floating research platform as the sun rose over the Pacific Ocean. 6 months had passed since the first contact failure, and now he coordinated the largest marine intelligence project in human history. Ships and floating labs from 12 nations had gathered in international waters, creating a temporary city on the sea. The platform buzzed with activity as scientists prepared for the Galactic Council's second evaluation. Underwater cables connected research stations across hundreds of miles, allowing whale and dolphin populations from different regions to communicate and work together on the same problems. "Status report," Hyun-woo called to his team of international researchers. Dr. Nam Yoon-ji looked up from her communication monitoring station. "The network is active. We have whale populations from Alaska to Australia connected through our relay system. The dolphins are responding well to the long-distance collaboration protocols." This was the breakthrough that had changed everything. 3 months ago, Yunji had discovered that whale songs could carry mathematical information across entire ocean basins. A humpback whale near Korea would work on part of a problem, then share its progress through song with whales thousands of miles away. Those distant whales would continue the work and pass their improvements to other populations. The ocean itself had become a massive thinking network, with cetacean minds connected across the planet's largest communication system. The Japanese team reports their orcapods are ready, called out Dr. Tanaka from the communication center. The Russian Arctic whales are also participating. They seem excited about the new challenge problems. Hyun-woo nodded. Today would determine whether Earth earned its place in galactic civilization or remained isolated for generations. The Velari had agreed to observe a demonstration after receiving evidence of the cetaceans' mathematical abilities. But they remained skeptical that lower life forms could surpass advanced alien intelligence. The test was scheduled for noon. Quentalith had provided a mathematical problem that Velari scientists had been unable to solve for over 200 years. It involved complex relationships between dark matter, quantum mechanics, and multidimensional space-time. Even with their advanced computers, the Velari could only achieve partial solutions. Incoming transmission from the Velari ship, announced the communications officer. The alien vessel appeared on the horizon, its crystal-like structure catching sunlight like a floating prism. Quentalith's musical voice came through the speakers clearly. "We are prepared to observe your demonstration, humans. Present your alleged mathematical solution processors." Hyun-woo activated the underwater viewing systems. Giant screens lowered into the water around the research platform, displaying holographic representations of the problem. The mathematics appeared as glowing three-dimensional structures that extended deep underwater where the cetaceans could see and interact with them. Almost immediately, the response began. Dolphins from 6 different pods swam toward the displays, their echolocation calls creating complex patterns as they analyzed the problem structure. Within minutes, they had identified key relationships and marked important connection points with precise movements. Then, the whales joined in. Bekho's song echoed across the water, but this time it was joined by voices from around the Pacific. Blue whales near California added deep harmonies that represented fundamental calculations. Humpbacks from Australian waters contributed rhythmic patterns that solved intermediate steps. Arctic whales from the Bering Sea provided the mathematical framework that tied everything together. It was like listening to a symphony composed of pure thought, with each voice representing a different aspect of cosmic mathematics. Impossible. Quentalith's voice came through the speakers. Multiple organisms cannot coordinate complex calculations across such distances, but the evidence was undeniable. The floating research platform's screens showed the mathematical progress in real time. Dolphin pattern recognition abilities identified shortcuts through 11-dimensional calculations. Whale deep processing power worked through quantum mechanical relationships that challenged the limits of known physics. Orcas synthesized the different approaches into unified solutions. Most remarkably, the cetaceans were correcting errors in the Velari's original problem formulation. "Dr. O," called Sujin from her analysis station, "the whales are identifying fundamental mistakes in the alien mathematics. Look at these corrections they're suggesting. The modifications were elegant and precise. Where Velari mathematicians had assumed certain relationships between quantum states, the whales demonstrated that those relationships were incomplete. Their songs revealed deeper connections that the aliens had missed entirely." Quentalith's ship moved closer to the platform. "How long have these creatures possessed such capabilities?" "We think they've always had them," Hyun-woo replied. "We just never looked in the right places or asked the right questions." The demonstration continued for 6 hours. Each problem the Velari presented, the cetacean network solved faster and more completely than alien mathematicians had achieved in decades of work. But they did more than solve problems. They revealed new ways of thinking about mathematics itself. A blue whale named Wu Sung, working with dolphin partners from 3 different pods, developed a proof that unified several competing theories about the nature of space and time. The proof was so fundamentally correct that it changed how observers understood the basic structure of reality. Yunji monitored the communications network as mathematical insights flowed between cetacean populations across the globe. The information sharing is incredible. A whale in the Arctic develops an insight about quantum mechanics, and within hours, dolphins in the South Pacific are applying that insight to solve related problems. As the sun began to set, Quentalith requested permission to board the platform. The crystal being moved carefully on unfamiliar human surfaces, its form reflecting the orange light of sunset. In our exploration of the galaxy, we have never encountered mathematical minds like these, it admitted to Hyun-woo. Our people think in rigid, logical patterns. These ocean creatures demonstrate fluid, intuitive, yet precise thinking that represents an entirely new form of cosmic intelligence. Through the platform's underwater windows, they could see the continuing collaboration. Dolphins traced geometric patterns with streams of bubbles, while whales sang equations that described the fundamental forces of the universe. Their work was beautiful and profound. Mathematics transformed into art. What you have shown us today changes our understanding of intelligence itself, Quentalith continued. We assumed advanced thinking required specific technological development. Your ocean creatures prove that profound mathematical capability can exist in forms we never imagined. Word of the demonstration spread through galactic communication, networks faster than light. Other alien civilizations learned that Earth possessed mathematical minds that could solve problems which had stumped galactic science for centuries. The Valari ship remained in Earth orbit for 3 more days, downloading every piece of cetacean mathematical work the humans could provide. Other alien species sent representatives to observe and learn from Earth's unique form of intelligence. As Hyun-woo watched the aliens study recordings of whale songs and dolphin patterns, he realized that humanity's relationship with the galaxy was changing in ways no one had expected. Earth wasn't joining galactic civilization as junior members. They were bringing gifts that enriched everyone. The ocean's mathematical symphonies continued through the night, songs of intelligence that connected minds across impossible distances, proving that the universe's greatest treasures often existed in the most unexpected places. The Valari were not easily convinced. Despite the impressive demonstration on the floating platform, Quentalith demanded more proof. 3 weeks after the first test, additional Valari ships arrived in Earth orbit, carrying some of the most brilliant mathematical minds in their civilization. Dr. Sim Young-ho served as humanity's primary liaison during the extended evaluation period. He had been chosen for his diplomatic skills and his growing understanding of cetacean intelligence. Each day brought new challenges as the aliens presented increasingly complex problems designed to find the limits of the ocean dwellers' capabilities. They're testing us systematically, Young-ho explained to the international team during a morning briefing. Each problem is designed to be harder than the last. They want to see where the cetaceans fail. Instead, each test revealed new depths of mathematical understanding that amazed both humans and aliens alike. The second week of testing brought a problem involving 17-dimensional space-time calculations that had puzzled Valari scientists for 3 centuries. The mathematics required understanding how quantum particles behaved across multiple universal layers simultaneously. Wu Sung, the massive blue whale who had become the star of the research project, approached this challenge differently than previous problems. Instead of working alone or with his usual dolphin partners, he called to whale populations across 3 oceans. Within hours, a mathematical conversation began that spanned half the planet. Blue whales in the North Atlantic contributed fundamental harmonic structures. Humpbacks in the Indian Ocean added rhythmic patterns that represented particle interactions. Sperm whales diving in the deepest trenches provided calculations based on pressure relationships that existed nowhere else on Earth. "Listen to this," said Dr. Kim Yoo-jin, the project's new acoustic specialist. She played recordings of the whale songs through the platform's speakers. Even translated into human mathematical notation, the beauty was overwhelming. They're not just solving the problem. They're composing mathematical music that describes the basic structure of reality. The solution came after 36 hours of continuous cetacean collaboration. Not only did they solve the 17-dimensional problem, but they identified 6 fundamental errors in the Volari's original assumptions about how multiple universes connected to each other. Quentalith studied the results in silence for a long time. When it finally spoke, its musical voice carried what sounded like awe. "This solution surpasses our greatest achievements in multidimensional mathematics. How is this possible from creatures we classified as primitive?" Young-ho had learned not to take offense at the aliens' terminology. "Perhaps the classification system needs revision. Intelligence takes many forms." The challenges continued. A group of orcapods led by Seul-gi tackled problems involving black hole mathematics that had stumped galactic physicists for millennia. Working together with sperm whales who understood deep ocean pressure dynamics, they developed equations that described what happened to information when it crossed event horizons. Their solution was so elegant and fundamentally correct that it revolutionized galactic understanding of how black holes affected space-time. The mathematics were beautiful in their simplicity, revealing truths about the universe that complex alien computers had never found. "We need to reconsider everything we thought we knew about intelligence," admitted another Volari scientist who called itself Morthine. "These ocean creatures think in ways that surpass our capabilities." But the most significant breakthrough came during the 3rd week of testing. The Volari presented what they called the unity problem, a mathematical challenge that required understanding how all fundamental forces in the universe connected to each other. It was the kind of equation that promised to unlock secrets about the nature of existence itself. The cetaceans' response surprised everyone. Instead of immediately attacking the problem, they seemed to be discussing it among themselves. Whale songs carried back and forth across ocean basins for 3 days without any apparent mathematical progress. "What are they doing?" asked Quentalith. "Are they unable to process this challenge?" Young-ho consulted with Hana, who had been monitoring the cetacean communications. "I think they're debating approach methodology," she said. "This is the first time we've seen them take so long to begin working on a problem." On the 4th day, the whales began to sing. What emerged was unlike anything they had produced before. Every cetacean species participated: blue whales, humpbacks, sperm whales, orcas, and dozens of dolphin pods around the world. Their combined mathematical symphony created a unified field equation that described how gravity, electromagnetism, and nuclear forces were all expressions of a single underlying reality. The equation was perfect. It was so fundamentally correct that it explained phenomena the Volari had observed but never understood. It reconciled competing theories that had divided galactic science for thousands of years. "Impossible," whispered Morthane. "We have worked on unified field theory for millennia. How did they solve it so quickly?" Dr. Park Ji-hoon, who had been analyzing the cetacean thought processes, offered an explanation. "I think they've been working on this problem for a very long time, maybe centuries. The songs whales have been singing for generations might have been mathematical discussions we never recognized. The implications were staggering. While humans had been focusing on technology and aliens had been developing rigid computational systems, Earth's whales had been quietly developing the most advanced mathematical understanding in the known galaxy. The unified field equations spread through galactic communication networks within days. Scientists from dozens of alien civilizations requested copies and explanations. The mathematical breakthrough promised to advance galactic technology by centuries. But for the cetaceans, It seemed like just another problem solved. They continued their daily activities, playing, feeding, socializing, as if revolutionizing galactic science was simply what minds like theirs naturally did. Quentalith spent hours studying recordings of whale songs, trying to understand how such profound intelligence could exist in forms so different from its own crystalline thought patterns. "Your ocean creatures have achieved something we believed impossible," it finally told Young Ho. "They have developed intuitive understanding of mathematical truths that we can only approach through complex calculations. This represents a form of cosmic intelligence we have never encountered." As news of Earth's mathematical breakthrough spread through the galaxy, other alien species began requesting permission to visit and learn from the cetaceans. The planet that had been rejected for Galactic Council membership was suddenly the most sought-after destination in known space. Young Ho watched the sunset paint the ocean in brilliant colors as whale songs echoed across the water. Those songs now carried new meaning. They weren't just the voices of Earth's marine mammals. They were the expressions of the galaxy's most profound mathematical minds, sharing insights that would shape cosmic understanding for generations to come. The ocean had revealed its greatest secret, intelligence that flowed like water itself, deep and powerful and beautiful beyond human imagination. 1 year after the failed first evaluation, Earth received an invitation that changed everything. Not only was humanity accepted into the Galactic Council, but they were invited to join the highest scientific committee in known space. The Cosmics Mathematics Institute requested Earth's cetaceans as founding members of their new research division. Dr. Ko Hyun-ah stood in the control room of the massive Oceanic Communication Center they had built off the coast of Jeju Island. The facility looked like a floating city with underwater research labs extending deep into the ocean. Advanced alien technology, gifted by grateful galactic civilizations, allowed the cetaceans to communicate directly with mathematical minds across the galaxy. "Incoming transmission from the Andromeda Mathematics Collective," announced the communications officer. "They're requesting help with multi-dimensional topology problems again." Hyuna smiled. In the months since the cetaceans' mathematical abilities became known throughout the galaxy, Earth had become the most important center of advanced mathematics in known space. Alien civilizations sent their most challenging problems to the ocean dwellers, knowing they would receive solutions that surpassed anything their own computers could achieve. Through the facility's massive underwater viewing windows, she could see Dong Hyun and his pod working with holographic displays that showed mathematical structures from 12 different alien civilizations. The dolphins approached each problem with what could only be described as joy, treating the most complex cosmic equations like entertaining puzzles. "The whales are ready to begin the Galactic Unified Theory Project," called Dr. Han Gildong from the engineering section. Gildong led the teams that translated cetacean mathematical insights into practical technology. Whale-developed equations had already advanced human space travel by centuries and provided clean energy solutions that transformed civilization. The Galactic Unified Theory was the most ambitious project yet attempted. Representatives from 47 different alien species had contributed their greatest unsolved mathematical challenges. The goal was to create a single theoretical framework that could explain every phenomenon in the known universe. For most civilizations, such a project would take millennia. The cetaceans had been working on it for 3 months and were approaching completion. Baekho's song echoed through the underwater speakers, joined by voices from whale populations around the world. But now those voices were joined by others, alien mathematical minds from across the galaxy who had learned to participate in the Oceanic Thinking Network. The song had become a truly cosmic symphony of intelligence. "Translation coming through now," reported the language team. The whale songs appeared on screens as flowing mathematical equations that described the relationships between matter, energy, consciousness, and the fabric of space-time itself. Dr. Lee Min-jun, the facility's chief mathematician, stared at the equations in amazement. They're not just solving individual problems anymore. They're showing us how everything connects. This is mathematics that explains the fundamental nature of existence. The breakthrough had happened gradually over the past year. As more alien civilizations learned about Earth's cetaceans, they began sharing their own mathematical traditions. The whales and dolphins absorbed these different approaches to cosmic mathematics, combining them with their own intuitive understanding to create something entirely new. They had developed a form of universal mathematical language that any intelligent species could understand. More importantly, they had proven that intelligence itself was a fundamental force of the universe, like gravity or electromagnetism. "Ceremony preparations are complete," announced the event coordinator. Today was the official ceremony where Earth would join the Galactic Council as a full member. Dr. Kim Seok, who had led the failed first evaluation, would represent humanity at the acceptance ceremony. But everyone knew the real stars were swimming in the depths below. The ceremony took place both on the surface and underwater. Alien delegates from across the galaxy gathered on floating platforms, while cetacean representatives participated through advanced holographic systems that allowed them to appear alongside the other attendees. Seok stood at the podium, but the massive underwater viewing walls showed the true heroes of the day. Hundreds of whales and dolphins swam in perfect formations, their mathematical songs creating patterns of light and sound that represented their ongoing contributions to cosmic understanding. Quentalith approached the podium to deliver the formal acceptance. The crystal being had become something like a friend to the human research team over the past year, fascinated by the new forms of intelligence Earth had revealed. "When we first evaluated your species, we made assumptions about intelligence based on our own limited experience," it said, its musical voice carrying across the water. "We measured your worth by technological achievements and rigid mathematical capabilities. We failed to recognize that the greatest minds on your planet existed in forms we had never imagined." The Volari leader gestured toward the underwater displays where cetaceans continued their mathematical work. "Your ocean dwellers have taught the galaxy that intelligence cannot be measured by technology alone. They have shown us that the most profound mathematical truths can be discovered through intuition, collaboration, and forms of thinking that transcend individual consciousness." As the formal acceptance concluded, the real celebration began underwater. Whale songs from around the world joined in a mathematical composition that told the story of cosmic evolution, from the birth of the first stars to the emergence of conscious minds capable of understanding their own existence. The song was beautiful beyond description. It was mathematics transformed into art, science expressed through pure emotion, intelligence celebrating its own infinite potential. Young dolphins and whales, trained by both their elders and human partners, swam alongside the adults. They represented not just Earth's future in galactic civilization, but perhaps the next step in the evolution of mathematical thinking itself. Hyuna watched from the control room as representatives from dozens of alien civilizations studied the cetacean mathematical performances. Many of these species were already sending their brightest minds to study on Earth, hoping to learn new ways of approaching cosmic problems. "Status report from the deep research stations," called the operations manager. "The abyssal whale populations are beginning preliminary work on transdimensional mathematics. They think they've found mathematical structures that exist between universes. It seemed there was no limit to what Earth's oceanic minds could achieve. Each month brought new discoveries that revolutionized galactic understanding of reality itself." The cetaceans approached these cosmic mysteries with the same playful curiosity they had always shown, treating the secrets of existence like fascinating games to be explored and understood. As the ceremony concluded and alien delegates began returning to their ships, Seok joined Hyuna at the viewing windows. Below them, The mathematical symphony continued. Whales and dolphins worked together on problems that would shape the future of cosmic civilization, their songs carrying insights that reached across the galaxy. "Who would have thought?" Siak said, quietly. "All those years we spent trying to impress the galaxy with our technology, and our greatest achievement was learning to listen to the minds that had been swimming in our oceans all along. In the depths of Earth's seas, the great mathematical..." Conversation continued. Cetacean minds explored the deepest mysteries of existence, their songs weaving together insights from across the galaxy into new understanding that expanded the boundaries of what was possible. The universe had found its voice in the ocean's depths, and that voice was singing equations that described the infinite beauty of conscious minds discovering their own cosmic significance. Humanity had earned its place among the stars not through the achievements of human intelligence, but by recognizing and nurturing the profound mathematical genius that had always existed in Earth's waters, waiting patiently for the moment when the galaxy was ready to listen to the ocean's deep wisdom.